Hello everyone. Once again I welcome to you all. Students, as you all know that we have already covered the first four part of solid state chemistry. In today's class we will be discussing this fifth part, and the topic for today's class is imperfection or defects in solid. Now let us start today's class. See, imperfection or defects in solid. Students, in the beginning of this chapter we have already discussed that a crystalline substance, there is a regular arrangement of constituent particles. However, generally the constituent particles are not arranged in a definite order. It has been found that the arrangement is not so perfect. Right? Now this actually happens because we know that a crystalline solid is made up of large number of small crystals. And somehow in these crystals the constituent particles are not arranged in a definite order. This may happen due to many reasons, because one of the reason is that during the process of crystallization, which sometimes occurs at a very fast rate or at a very moderate rate, and at that time the constituent particles are not getting enough time to arrange themselves in a definite order or in a perfect order, we can say. So due to this, there occurs some defect or imperfection in the solid. So that is called as the defect. Now here I have written the definition of defects. The departure or the deviation from the perfectly ordered arrangement of constituent particle in a crystalline substance is called as imperfection or defect. Right. Now crystal defects are of different types. It is broadly classified into two categories. Here you can see in this figure, the first one is the point defect and the second is the line defect. So point defect is further classified into three types. The first one, stoichiometric defect, non-stoichiometric defect and impurity defect. The stoichiometric defect itself is divided into again further types. The one is called as the vacancy defect, interstitial defect, Schottky defect and Frenkel defect. Right. In the same way, the non-stoichiometric defects are again further classified into different types: metal excess defect and metal deficiency defect. Now this metal excess defect is arise due to 2 points. The first one is the presence of anion vacancy and the second is presence of extra cation interstitials. Right. So we will discuss all these points one by one. Similarly, the line defect is again divided into two types: the edge location and the screw dislocation. So we will discuss all this in our coming topic. So let us start. See, the first one is the point defect and line defect. See, the point defect is a type of defect which arises when there is a deviation or imperfection occurs from the ideal arrangement around a particular atom or a point in a crystalline substance. We call it as a point defect. You can see here in this image that the particular space remains vacant. Okay, so this is around the particular atom and this is called as the point defect. Okay, one particular atom or constituent particle is missing from its point and it's create a point defect. So in the same way, the line defect is the one in which there is an imperfection or deviation occurs from the ideal arrangement in the entire row of the lattice point. You can see here in this picture, right? The entire row is getting disturbed. And this type of imperfection which occurs along the entire row of the crystalline lattice, we call it as a line defect. So this we have just now seen that the point defect are of different types: the stoichiometric defect, non-stoichiometric defect. So first we will discuss about the stoichiometric defect. See student, stoichiometric defect is a type of defect which occurs in the ionic compound in which the ratio between the cations and anions are same as represented by their molecular formula. Okay, we can say that the stoichiometry of the solid maintained here. It's not getting disturbed. It is same as represented by its molecular formula. So this is called a stoichiometric defect. Or we can say it is also called as intrinsic defect or thermodynamic defect, because here the heat affects the crystal. So it is again of two types. One is the vacancy defect and the other one is the interstitial defect. Right. So first we will discuss about the vacancy defect. You can see here in the picture, this is the vacancy defect. Now the vacancy defect, it arises in the crystalline solid when there's a vacant space in the lattice point. You can see the two lattice point here remains vacant. It means that the two constituent particles from these particular lattice point have gone missing. So due to that, it creates a vacancy over there. So it is called as vacancy defect. Now, due to this vacant space, the overall density of the crystal decreases, right? We know that density is equal to mass by volume. So if the overall mass decreases, density also decreases. Okay. So you can see here that in vacancy defect, the density of the crystal decreases, right? And the second one is the interstitial defect. Now you know what are the interstitial sites. Interstitial sites are the empty or the vacant sites present between the constituent particles, which we have already learned in our previous classes. Okay. Now in this type of defect, the constituent particles have occupied the interstitial sites or the vacant sites between the constituent particles, as shown in this figure, right? Now you can see that two constituent particles are present in between the lattice. Okay, so this type of defect is called as interstitial defect. Now in this case, the overall density of the crystal increases. As the constituent particles are added in the lattice structure, then the overall density here increases because the mass of the crystal increases. So these two types of defect are generally found in the non-ionic solid, right? Now next we will discuss the defects in case of ionic solid. I think it's clear to you. Stoichiometric defects are of two types, vacancy and interstitial defect. In vacancy defect, the crystal ions are missing from their points, lattice point, and creating a vacancy over there. And in interstitial defect, the constituent particles are present in the vacant space or the interstitial space in between the crystal lattice. Defects in ionic solid. So the last we have discussed the defects in the non-ionic solid. Now here we will discuss the defects in the ionic solid. In case of ionic solid, there are two types of defect, Schottky defect and Frenkel defect. So first we will discuss about the Schottky defect. Now Schottky defect is a type of defect which arises when a particular cation and an anion is missing from their lattice site. Listen carefully, I am telling that they are missing from their lattice point. They have not occupied any interstitial site, but they are completely missing from their lattice sites. Okay, now you can see here in this picture that a particular cation and anion is missing from their lattice point, right? Now what are the important features of this Schottky defect? See students, as you know that one cation and one anion is missing from their lattice point and they creating a pair of hole over there. Or you can see they create a vacancy over there, right? So the overall electrical neutrality here in this case is maintained because the cations and anions are equal in number which are missing from here, right? So now can you tell me that what about the density of the crystal here? As one cation and one anion is missing from their lattice point, the overall mass of the crystal lattice decreases. As a result, the density of the crystal also decreases here. Okay, now this type of defect is called a Schottky defect. Now one important thing is that this type of defect are generally found in the compound, ionic compound, in which there is a high coordination number, right? And second one is that there is a small difference in the size of cations and anions. Okay. Now you see the example I have written here, sodium chloride, potassium bromide, silver bromide, etc. So this is about the Schottky defect. The next one is the Frenkel defect. Now in this case what happens, the constituent particles are missing from its lattice site and they have occupied the interstitial site. You can see in this figure that a constituent particle is left or it's dislocated from its particular place or particular lattice point and have occupied the interstitial sites. As it occupies the interstitial site, it creates a vacancy or a hole over there. It is also called as the combination of interstitial defect and vacancy defect, because we can see both in this particular defect. As a particular ion is missing from its place, so it creates a vacancy over there, and therefore it is called as vacancy defect. At the same time, the constituent particle occupies an interstitial site, and we call it as an interstitial defect also. So this particular Frankel defect is a combination of interstitial defect and vacancy defect, right? Generally, in this case, the cations occupies the interstitial sites, right? Because the cations are generally smaller in size as compared to the anion. Being smaller, they can easily fit into the interstitial sites. So they generally go into the interstitial sites, the cations. Okay. Now in this type of defect also, the electrical neutrality as well as the stoichiometry of the compound is maintained. Okay. Here some examples are given: silver chloride, silver bromide and silver iodide. This type of defect is also called as dislocation defect, because a particular cation is being dislocated from its place and is occupied some other site. Okay, it is not completely missing. It has just leave its position and occupied some other site, and that is the reason why it is also called as dislocation defect. Here is the difference between the Schottky defect and the Frankel defect. See, in Schottky defect, we have just now seen that equal number of cations and anions are missing from their lattice site. Okay, equal number of cations and equal number of anions are missing. Whereas in case of Frankel defect, a cation leaves its normal lattice site and occupies the interstitial site. In case of Schottky defect, it is mainly found in the high ionic compound with high coordination number, whereas the cations and anions are generally of similar size. Whereas in Frankel defect, these are found in the ionic compounds with low coordination number and where the anions are much larger than the size of cation. Or we can say there is a large difference between the size of cation and anion. Now the most important difference or the most important point is that in case of Schottky defect, the density of the solid decreases. Whereas in case of Frankel defect, the density of the solid remains same. Okay, it is because the cation is not missing, but it has just leave its space and occupy some other space. It has just dislocated there. So it has not just missing but dislocated, and that is the reason why the density here remains same. Okay. So this is all for today's class, students. In the next class, we will discuss about the non-stoichiometric defect. Okay. Now I have a question for you, which is very important, and many times it comes in the board exam in 1 mark. So you have to tell me that which particular ionic solid shows both the Schottky defect as well as the Frankel defect. The answer is given in this video only. You have to go through it and you have to tell me that which type of ionic solid shows both the Schottky and the Frankel defect. This is very important question. Many times this question comes in the previous board exams, right? So that's all for today's class. Thank you.